So guys, we talked about functions. And I gave like, the way I describe function, the first thing I said, this function can be given as set of ordered pairs. Okay? So if you know that, and what's the restriction for a function to be given in terms of set of ordered pairs, right? So what's the restriction? What's the restriction, the function to, it was one of the questions today of the quiz.
For one x, there cannot be zero.
Sharon, go ahead.
For each x, there can be two or more y.
Yes, for same x, you cannot have two different y values. So that's all you have to remember as function, okay, to be a function in terms of ordered pair. Now, so we said function as ordered pair, and then we said function as a graph, right? So graph is also set of ordered pairs. All these are set of ordered pairs. We also say function as what? Equation, which is what? Which can be given as a formula, and we went through so many equations, different type of formulas, where basic functions, types of functions, right? And also we said function number 4, what was it we said?
That's the definition.
Yeah, that's just the definition is, for me the definition is, I'm going to go through another thing, this is the definition. I said use the definition, but I didn't describe this in detail, but I just said set of ordered pairs, right? So now I'm going back and I'm going to explain in another way what is a function, okay? So number 4, what did I say?
Function machine.
A function machine. So I explained to you guys what's the domain, what's the range in terms of function machine, right? You something what you're able to put like inputs, whatever, something you can use as input is your domain. If you can't use it as an input, it's not a domain for the machine to work, right? So domain is the numbers that only you can use. Range is the numbers that the machine is outputting, right? The machine is giving you back, right? So if the machine cannot give a number for the number that we input, then that's not part of the range, right? Sometimes you can have irrational number, not irrational, so there's a complex number, not a real number. Then not a real number is not part of the range, right? Okay, so what's the other thing we discussed? So I said number 1, the definition. So now I'm going to explain number 1 in when I meant what is number 1 as definition is also you can give a function as set of ordered pairs. Okay? So now I'm going to say function definition is set of ordered pairs. It's a set of ordered pairs. And such that you need to write this, right? Such that blah blah blah, what is it, right? Every x, they cannot have, for each x, they cannot have 2 different y values. So you guys already have that. So here we are going to, the book has this definition, I want to explain this little furthermore. So you guys can also see functions can be given as arrow diagram. So I didn't want to go through this last class meeting in detail, but I'm showing it to you now because you have more knowledge of functions now, okay? So we have 2 sets. So we say set A here, set B here, and let's say we have A, B, C, D, E, and 1, 2, 3, 4, 5. And if you have a diagram like this, so what is, this is is a mapping from set A to set B. It's a mapping from set A to set B. So whenever we have a mapping, that means it is giving us a set of ordered pairs, right? So mapping, set A mapping, from mapping where the mapping is starting, this is called the domain. And this is called the, where it's mapped to call the range, okay? So again, domain. So what's the domain here? Domain is A, B, here this is not an interval, this is individual items, right? It's like $1, $2, $3, right? So the domain is, what the example we did, the function machine, is the same thing here. So what's the domain here? A, B, C, D, and E. This is only the domain. What's the range here? 1, 2, 3, 4, and 5. This is the range. Now, in this, is this a function? Is this a function? Yes, so take set of ordered pairs that creating by this arrow diagram. So I'm calling this operation here, I'm going to call this F. This whole, so F is equal to, what we have? AN 1, BN 2, CN 3, DN 4, EN 5. So is this a function? Is a function. Okay? So this is a function. Now, you guys understand this? So the book has it, we can also, this is basically the definition. Okay, because at the end we get a set of ordered pairs with a restriction, right? It's applied, the restriction applied to this, right? So you can also see function as, without giving the ordered pairs, you can also see as what? What's this whole diagram called?
Arrow diagram.
Arrow diagram. So whenever you are given, a function is given in terms of arrow diagram, right? We can also determine whether it's a, whenever arrow diagram is given, we can also determine whether it's a function or not, right? So maybe a test question like this now. Test question like this. This is A, this is B, two sets, and I have X, Y, Z, R, and I have P, Q, S, T, U, and I have this. Question is, function or not? Not function. What is this? Not a function, right? What's the reason? So sometimes, remember we went through this, if it's not a function, I can ask you to explain, right? Explain, what's the explanation? We have XP, this ordered pair. Now we don't have to give ordered pairs only in terms of numbers. At the beginning I gave only in terms of numbers, right? But now we know what's, so we can also have this now, right? So what's the other one? XP and XQ. XP and XQ, these two ordered pairs have the same domain, same X coordinate with two different Y coordinates. So you need to write your explanation, same X coordinate with two different Y coordinates. Or you can say same independent variable with two different dependent variable. Okay? Same independent, first value is called the independent, second value is the dependent. We know we discussed this before. Okay, because you don't see a Y value here, this is the depending variable. This is the independent variable. So you don't have to put another, you don't have to say Z and T and Z and S. You don't have to give another example, another two ordered pair. So you give these two ordered pairs only, your explanation is done. It only takes one. Okay? Okay guys, so. Okay, now a couple of things I need to do from chapter 2.2 where we missed. We missed a couple of things. Go back to okay. Page 'Oh, we talked about domain of a function last class meeting. We did two examples, right? We were doing last class meeting, we did the domain of functions, right? So I did two examples. What was the two examples I did? Example number 1, example number 2. I did two, correct? What was the first one I did?
The ones from the book.
Yeah.
F of x equals x cubed minus x squared minus 4x plus 4.
Minus?
4x plus 4.
So we did this, right? Did we do this?
Yes. Number 66 from the book.
Find the domain of function. That's one to find all x. Yeah. Domain of function is problem number 71 through 82. So this is 71 through 82. This one we did find the x value such that f of x equal to 0. This is just finding the x value only. That means find the x value such. This means finding the zeros. Later on we are going to talk about finding the zeros of the function. X values means where the y, we talked about this many times. F of x 0 means y is 0. When the y is 0, find the value of x. This is not the domain. Domain is all the x values, all possible x values such that we get a real number for the y value, right? So, what was the example I did? I did two examples.
F of x equals square root of x minus 7.
Square root of x minus 7. Yes, we did this, right? So we did the example similar like this for the quiz today. And example number 2, we said f of x is equal to, I had like x minus 5 here or something.
1 over x plus 4.
So we did these two examples, correct? Right? So we did these two. So example number 3, so I'm going to do another problem from the book. How about number 79? Number 79 and number 81 are similar to this. Number 79 now. Example number 3, number 79. So this is number 79 from 2.2. F of x is equal to x minus 1 square root over x minus 4. So guys, we have this function now.
And what's the question asking?
So the question is find the domain of this function. Okay? That's the question. We have to focus on the question. So domain means we look for the restrictions, take out the restrictions and write the remaining all possible ones in interval notation, correct? So what's the restriction here? Whenever we did these two examples, right? These are two examples we did. We know how to get a restriction whenever we have a square root. We know how to get a restriction whenever we have a rational, right? But this one, example number 3, what do we have? We have square root and a rational. Can we do this now? So what do you need to do? Let's work with the square root. There's the one for the square root, because whatever inside need to be greater than or equal to 0. So solve this. X has to be greater than or equal to 1. So this is one answer. We are not done yet. Work with the other one. Also, or n, what's the other restriction? X minus 4, this whole thing cannot be equal to 0. So this will give x cannot be equal to 4. So these are the two restrictions. So now let's draw this on the number line and take out this restriction. X has to be greater than or equal to 1. Where are they? Greater than or equal to 1. So it is 1 here. Greater than or equal to, you take this, correct? And then go where? All the way to the right. All the way to the right. So this says take all these values. Can I take any value here? No. But is it only this we have to worry about now? No, we have to work with this also. What is this says? X cannot be. So is 4 included in here?
Yes.
Yes, right? 1 through 4, 4 is there. So what do you need to do now? You go to 4 and put an open circle. So that means this 4 is missing this point. So now look at this and write the domain. All the numbers in this diagram is the domain. All the numbers that we have colored like this. So what's the domain here? 1 through 4, close, open, union, 4 through infinity, open, open. This is the domain. Guys, you understand this? Everybody following this? So we have to be very careful to look for all restrictions. Restrictions we cannot use. They can damage, they can give lots of problems, they are not going to work. So we have to eliminate those. Okay? So this is similar test question. So when it's supposed to find domain, I will have 3-4 different questions. One of these is very similar to this. Okay? Test question. Next one. Test question. So today I had these two for the quiz. See, the test is very, very easy if I have said this so many times now. Make sure you know how to do your class notes problems. Okay? Let's do one more real fast. I'm doing, which one I said I'll do? Number 80?
81.
Number 80. Number 81. So number 81. Same, find the domain. 2.281. F of x is equal to what here?
X minus 4.
X
Negative 4.
minus 4 over square root of x like that. So same thing, same thing. Here we need to say the restrictions. What is it?
X is not equal to 0.
Here, look at this here. Do we have to do anything to the numerator? No, we don't have to do anything to the numerator. There's no square root signs in the numerator. Numerator can go to 0, it's okay. Any number, 0 divided by any number is 0. So 0 is a value, right? So here we need to say this now. What's the first thing we are going to say?
Can't be negative.
X has to be greater than or equal to 0. That means X cannot be a negative number.
It can also not be 0.
Also now we have to say also, this is in the denominator. So the same thing we have to take it twice here. If what happened, X is equal to 0. Square root of 0 is 0, correct? So we can't let the denominator goes to 0. So here there's a restriction and a square root. Okay? So what else we are going to say? X not equal to 0. So now you, according to this is like a working graph. You look at the working graph. X is greater than or equal to 0, the first one. Starting with this, greater than or equal to 0, this way, everything, right?
Should it be open?
But then we need to take the 0 out. We need to use this also, right? So this is open here. So now this is open, 0 is open here. So it's, what's the final answer? Domain.
0, open.
0 open, that means not included, and to infinity.
Open.
Open. Very good, guys, very good. Okay. Okay, so we did that, and then I'm going to do page difference quotient. What page is this? Page 192. Now this is also big time test question. Okay. Okay, so if you take, this is a quotient, this is a special quotient that we consider, especially when you guys go to pre-calculus class, probably in calculus class at the beginning. Have you guys heard of derivative?
Yes.
Yes. X plus h minus f of x over h. So this is called the difference quotient. Where h is not equal to 0. When h is not, this is called the difference quotient. Okay? Now you guys know what is x plus h. I'll explain this to you in a few minutes. Okay? So in calculus, we use the difference quotient to find the derivative of a function. Okay? So you guys will learn what is derivative means, all that means later on. Derivative means the slope of the function. When you have a graph that is like curve, the slope is changing instantaneously, right? It's not like the slope is the same everywhere. So this you guys will work how to find the slope of a function. This is the same thing as slope of a function when the function is a curve. Okay? Okay, so right now you don't have to worry about that. but you understand what that means, right? Eh? You have a graph like this. Is the slope is the same? No, slope is changing every second, every point. Slope is changing. Okay, so we'll talk about this later on again. So example for this. So everybody understand what is now, you guys? Let me do an example for this first. So find the difference quotient. Example number one, f of x is equal to x squared plus 3x minus 2. So f of x is given, find the different quotient. So this is similar to problem number 113 to 110. 103 to 106. Number 103 through 106. Okay. 2.2. So find the difference quotient. So what is the difference quotient? Given this, is equal to what? F of h cannot be equal to 0. So now substitute. All you have to do is evaluate what is this. So if f of x is equal to this, what is f of x plus h? F of x plus h is equal to what?
X squared plus 3x minus 2 plus 8.
Yeah, so this is equal to x plus h whole thing squared. Instead of x, you put x plus h, right? That's how we evaluate f of x. Because this whole thing is, if it's f of x, it was x squared, right? Now it's x plus h. So you need to substitute x plus h where you see x. So what do you get here?
3x.
X plus h. This is, we talked about this, how to evaluate a function for the given values of x, right? The given values of x is now x plus h. So all you have to do is substitute x plus h where you see x in the given function. So minus 2. So this is, now you guys can simplify this first if you prefer to simplify this first. I can write like this, f of x plus h minus f of x over h, so I'm doing the difference. So this whole thing is the x plus h, subtract, what is f of x now? This is f of x, correct? Isn't this f of x? F of x is this. So whatever f of x, you write there. This is f of x. See? F of x plus h is this. Subtract f of x. Are we done looking for difference quotient here? What do you need to do for difference quotient? Means this whole thing. This is a quotient. This is called the difference quotient. Quotient means there's a division of two things. Right? So whenever we take the difference quotient, we need to consider this and divide by h. So divide by h. Now guys, whenever we get something like this in algebra, we are not supposed to leave it like this, are we? We are not, right? What can we do? What can we do? We need to simplify this all the way. Okay? It's not saying us to solve this because we are looking for a difference quotient. So whatever here, whatever this mess, we are going to simplify. So simplify this. So different quotient f of x plus h minus f of x over h is equal to, just simplify, x squared plus 2xh plus h squared, you know, I foiled that, right? Minus, I need to distribute the minus sign inside the parentheses. Plus, I'm sorry, this is plus 3 times x plus 3h minus 2. Now what do I need to do? Distribute x squared minus 3x. What is it?
Plus 2.
Plus 2. Don't forget this. Everything over h. Simplify the numerator. This to this get cancelled. What do we have?
Choose cancel.
These get cancelled.
H squared equals 2x.
2xh. So we took this one plus
H squared
3h minus 2 and plus 2 also got cancelled over
Plus a squared. A squared.
We got the h squared.
2xh plus 3h
H squared.
H squared.
plus h squared over h. Right? Now look what we can do. Can we do something else here? We can factor h out here. What do you get when you factor h out? 2x plus 3 plus h over h. Now cancel this h to this h. So what's your final answer here? Different portion, 2x plus 3 plus h. Okay. Question?
Where did you get the 2H x1?
Huh?
Where did you get the 2H x1?
Where did we get 2xh?
Oh, yeah, when you fold them.
You foil
Where
it,
did we get 2xh, guys?
you foil it, x plus h.
Here we are foiling this, correct? We are foiling this means x plus h times x plus h. You multiply these two. Okay? Okay, so I'm not going to do another example of this. I think all you have to do is find the difference quotient means you work with this. And then you have to simplify. Use x plus h. You don't have to know exactly the diagram of how this works. All know that we are going to use this in calculus to find the derivative of a function. Okay? Okay, so we also talked about so I have that I did derivative function. Okay. So on piecewise functions, we talked about how to graph piecewise function, which we are going to do in 2.4, but we talked about it when it comes to 2.4, I'll go through it in again to do bit review, right? Now on 2.4, when you're supposed to evaluate functions, if you go through problem number, let's say problem number 49 through 52, so note here, I'm going to do this example. F of x is equal to 2x plus 1 and 2x plus 2. What type of function is this, class? Piecewise function. We talked about this. We know exactly what this means. Now here, given a function like this, so this is the, what we, direction says evaluate. Evaluate for the given value. Evaluate the function for the given values. We exactly know how to do this really good, right? But we didn't do an example where the function given is a piecewise function. Okay? So if it's a piecewise function is given, I'm doing problem number 49 on page 195. So part A is f of negative 1. Find f of negative 1. Part B is find f of 0.
Is that greater than or equal to?
Huh?
Is that greater than or equal to?
The second one, the 2x plus 2.
And part C is f of 2. Okay? Now given a function like this, piecewise functions, we know exactly how to graph these also. So we are very knowledgeable of lots of different types of functions now. If it's like f of x is equal to, we did this, x squared plus 2x plus 3, find f of negative 1. Do we know how to do this exactly? Yes, we know, right? We did this. This is, of course, yes. No problem, you substitute negative 1, simplify, we did that, right? Now here f of negative 1. Now, how will you do this? You know piecewise means we have, the function is using one rule for one part of the graph, using another rule for the another part, right? There's two rules here, not one rule. For certain domain numbers, the function is using one rule. Certain domain numbers, function is using a different rule. So whenever, we have to be careful which rule we are going to take this. There's two rules here, two formulas. Which rule are we using here?
2x plus 1.
X is negative 1 belongs to what domain? This one. So this one you can only use this rule. Remember when we even graph this using the real right domain numbers? So what is f of negative 1? We don't care this because this is for different rule, different domain. So 2 times negative 1 plus 1, which is equal to negative 2 plus 1 is negative. So f of negative 1 is equal to negative 1, that's the answer. That's it. Right? So I heard the question f of 2. See, we don't have to worry about this part here at all because in this rule, negative 1 is not part of the domain, right? Okay, f of 0, which one?
The 2x plus 2.
This one, right? 0 belongs to this rule. So all you have to do is consider which rule that you are supposed to use. Because we know the story behind this whole thing, right? We are using two different rules for different set of domain numbers. So make sure that whatever we have to evaluate belongs to that domain and use the corresponding rule for that domain. Does that make sense, class?
Yes.
Okay. So what do you get here? 2 times 0 plus 2 is equal to 2. So final answer is f of 0 is equal to 2. For this is one whole function, even though it has piecewise, two different, right, two different rules. What is f of 2? Which rule? Second one is equal to 2 times x plus 2. So 2 times 2 is 4 plus 2 is 6, right? Okay?